Okay, this is section 2.2, and we're still looking at linear transformations. Okay. And right now, this is, we're going to look at this remark 2.2.1, because actually they pack a lot into that, and I'm going to use a little bit different notation than they're using. They use the F, I'm going to use R. But so this is the idea that this is why matrices are important. Their remark is, they say, well, hey, it's easy to prove that if we have, say, T going from Rn to Rm. Now notice the subtle part here, they drop the A. They drop that A. And they say, if this is a linear transformation, okay, is a linear transformation, then they say actually it can be represented, okay, right, then it is TA, so in other words, represented by a matrix, okay, so it's represented by a matrix, and I can actually, if I can evaluate this transform, and I can tell you the columns of A. And the columns of A are given by A times, and they use an uppercase E. Usually you use a lowercase e. So A times E1, E2, and so forth up to A, E, N. Okay, so it's given by that, where E1 is the vector 1, 0, 0, dot, 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 down here to 0. The vector E2 is 0, 1, and then a bunch of zeros. And that just keeps going until you get to the vector En, and that would go 0, 0, all the way down here, 0, and 1 at the bottom. Okay, and let's just look at a kind of a quick example that, sure, that works out that way, just to look at some matrix multiplication. So take, some matrix A that is, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is from R3 to R3. And notice if I take A times E1, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1, 0, 0. And what happens? Well, I take the first row dotted with the column here, 1, 0, 0, and I just get the 1. Because I'll get 1 times 1 plus a couple zeros. And then second row, 4, 5, 6 times that, I get the 4. And then 7, 8, 9 times that, I get the 7. So you see, that is the first column of A. So, I might call it A1 as the first column. And then, again, if I do AE2, then there I have my 1, 2, 3, 4, 5, 6, 7, 8, 9. and I multiply by 0, 1, 0. Then again, you see I take that first row, 1, 2, 3, dotted with 0, 1, 0, and only the 2 gets multiplied, so I get a 2. 4, 5, 6, I'll just get the 5. 7, 8, 9, I'll just get the 8. And there's my second column of A. And then finally, AE3. And 1, 2, 3, 4, 5, 6, 7, 8, and 9. And 0, 0, 1. And again, you see 1, 2, 3 times that 0, 0, 1. We get the 3, and then the 6, and then the 9. Okay, so you see multiplying by these e's just gives us those columns. Now the e sub I are called the standard basis vectors of Rn. Okay, and the text also mentions these are unit vectors. Okay, because their length is 1. All right, so that is remark 2.2.1, and I just felt, they actually pack a lot into that little remark there, and so I thought it was worth expanding on that idea.